So recapping exercise 9F, one of the first skills I wanted you to understand was standard deviation. Standard deviation was the measure, for those who've forgotten, it's the measure of distance or difference or spread, whichever word that seems to make sense to you. It's a measure of distance, difference, spread about the mean. And the best example I could give you at the time was the scenario of if I was able to predict, I had a really good mathematical equation to predict your...
Me and Rahan said you don't have the booklets that you gave.
Oh, I'll go grab it later. Yeah. This is going to be a big recap for you then. I explained the idea intuitively to you that if one class had this type of prediction, so the number of hours they studied and what eta they actually get, so eta and then hours, versus this class, hours and eta, you naturally knew to tell me that the first class would have a lot more trust in my model of prediction versus the second class, because you can tell that the second class, I'm clearly not doing a really good prediction there. But how to do that, that's the understanding of what standard deviation is. So standard deviation is exactly what you're doing intuitively, right? But we can spell it out mathematically as well. So I'm not going to go through that explanation again, but the idea is obviously the smaller the distance, the smaller the error on average, that's a better prediction, okay? So standard deviation is the spread of your data about the mean. That's tells us more than the range and tells us more than the interquartile range, yeah? Gave you a formula. Now, normally year 12s would probably need to know the formula. Actually, they do need to know the formula. They don't need to know how to do it by hand per se, but out of curiosity, anyone remember what the rule was again? How do you find standard deviation? Because it was hinging on the idea of how to understand that theoretically. Don't need to know, it's on the front of your booklets, but what is the rule, Andrea?
X minus mu.
Yeah, mu.
The size of the population.
Yep. We're missing a few symbols here. What are we missing? Sum. So we need to add all these numbers together. So what numbers am I adding? I'm adding the actual data minus the mean. So remember the student's data minus what I predicted tells us the difference. Okay. Then what else am I missing? The square. And why do we square it again? Anyone remember my explanation? Why do we have to square it, Michelle?
Because if the distance between the mean and the actual thing is negative, then that's the way to get rid of it.
Yeah, so remember, if I just had two students as an example, and I had this prediction, if I was 10 off, so minus 10 off from a student, so I thought they would get 50, but they got 40, versus another student, I thought they would get 50, but they got 60, it's equally bad in the sense that my average error, or average distance, is 10% difference. But if I actually found the average of that, negative 10 plus 10 gives you 0. And then 0 divided by number of people I'm adding together, 0 divided by 2 is 0. But an average error of 0, what does that imply? Yeah, that I'm perfect. That I have no error at all. I have 0% error. But I actually have 10% error. And the reason why that occurs is because that's negative. If it's negative, the net error becomes a problem. That's why we square them. If we square them, then the negative 10 becomes 100. The positive 10% becomes 100 as well. That's equal distance. The problem with squaring it is that it's now inflating the actual error. I was only 10% off, I'm not 100% off. Yeah? That's why the formula had a square root. Okay, so that's just on the theoretical sense. If you didn't get it, doesn't matter, because I taught you how to find it on your CAS. Yeah, so one variable statistics, do the spreadsheet, watch my video again, just that bit to know how to do that on your CAS, because that allows you to find minimum, Q1, Q2, Q3, and maximum. It should tell you everything about this. It should tell you the sums, it should tell you the mean, it tells you the n So just a couple of buttons on your CAS, you'll get that. And I'll be testing that in your exam. Okay, I'll be testing that you can do that with your CAS because I don't expect you to sit there and actually type and figure it all manually. Okay, I expect you to do it on a CAS. Cool? So that was one skill, so standard deviation. Number two, I then introduced you to the understanding of the bell curve. Okay, there was a function for it, and it was a crazy formula which you do not need to know. This was root of 2 pi e to the negative half of x minus mu over standard deviation all squared. You don't need to know that. Okay, but this gives you that shape. That's essentially all you need to understand. Yeah, your CAS calculator already has this. And that's what I'm going to show you today. How do you find the area? Because there's only two pieces of information you need to know for this graph. This is your normal. This is your normal graph, okay, or the bell curve graph. You need two things. This symbol and this symbol. Let's remind ourselves again. What's mu? Again, what's mu? Yes, Andrea. It's the mean. Tells you the mean, so as long as you know the mean, which is where the average is, all the average sits right in the center. Okay, so the average sits right at the center. You just need to know the mean. And this symbol, sigma, Violet, standard deviation, which is the measure of spread around the mean. So standard deviation. If you just know those two, so what the mean is and what the standard deviation is, you can use your CAS to figure this out. Now, part of what you needed to know was what happens if you're one standard deviation less and above. So if you went from the mean, you added one standard deviation above and one standard deviation before, so between -1 and 1, how much of a percentage or area does this cover again? Can I please have, let's see who remembers this one, Rowan? So one standard deviation, mean plus or minus one standard deviation is approximately how much? No idea, Sean? 68, very good. So you got the -1 to 0. So remember, on your booklet, the very front page, it has a picture and it has this cut up into 34 and 34. It means that the one standard deviation, these are your own, so this is what I want you to know for your exam. It's 3 numbers and it's 3 key factors. It's mu, so the mean, plus or minus 1 standard deviation versus 2 standard deviations, plus or minus 3 standard deviations. So you got 68% of the data will sit between 1 standard deviation to the left and 1 standard deviation to the right of the mean. What about 2 standard deviations again? What's the percentage, Andrea? 95%. And the last number a lot of students tend to forget. Which one is that, Nishi? 99.7. Okay, and if you happen to forget this, you can also do it on a CAS, which I can show you now. So if you happen to forget it, you can actually figure out roughly what it looks like. Okay, so here we go. If you've got a CAS, I can show you how to work out these percentages. Here we go. Grab out a CAS. That's all you really need to know. That's it for the exam, yeah? Up until this point, knowing if you've got that picture of all the different sections, that will be helpful for you. Otherwise, if you know how to do the CAS, then you don't need to memorize it. Here we go. Here's your CAS. Go to calculator page. Remember, don't go to Scratchpad. Go to calculator. Once you're in the calculator page, go to menu. Probability, because that's obviously what we're working on. We're looking at the chances. And go to distributions, because we're looking at what type of distribution are we doing, and it's specifically normal. It's the normal distribution. So notice you've got these 3 things here. Whoops, 1, 2, 3. Normal PDF, normal CDF, and then inverse normal. For your sake, you only use normal CDF. CDF stands for cumulative. Okay, so we're looking at the cumulative, adding all the areas together, or the probability, which is under the curve. That's once you learn calculus, you understand that bit there. But normal CDF is the only one you use. So how does it work? Click on it. And look at this. As long as you know your mean and you know your standard deviation, which a normal curve, that function that I gave to you, it will always start as a basis as mean is 0, that's the center, and standard deviation of 1. So if you've forgotten what one standard deviation to the left is and one standard deviation to the right, you can actually type it in. You can put -1 to 1, so that's from -1 to the left, 1 to the right on the graph. So I'll go back to the graph again. So remember we said if the mean is right here, mean is 0, and I went 1 across to the left, so this is my boundary, and 1 to the right, that's my new boundary, then the calculator can work this out by norm CDF, and I put in my boundaries. I say from -1 to 1, where the mean is 0 and the standard deviation is 1. So this is your lower boundary. This is your upper boundary. This is your mu, and that's your standard deviation. Okay, so if I press enter, we should expect about 68%. Whoops, what am I doing? There we go, enter. There you go. That's an approximation. So when you study it, we learn 3 key numbers. We say 68, 95, 99.7. It's about 68.268, roughly there. Okay, so that's how you calculate. So you could have done the same thing. You could have copied this. If you didn't know, press up and down, highlight it, press enter, and it brings it down again. And you can just now change 2 standard deviations. So 2 to the left, 2 to the right, you said 95. There we go, it's approximately 95%. We said 3 standard deviations, so if I go 3 to the left and then 3 to the right, 99.7. Okay, and then remember how I talked about your study score? So we said study score, average is 30. Anyone remember what the standard deviation was for a study score? 7. 7. So you can actually work out what study score you want simply with your CAS as well. So let's say if I go to menu and I go to, where is it again? Probability, distributions, go to normal CDF. You know that the mean is 30. You know the standard deviation is 7. So what do you want? Do you want 40 and above, 35 and above? Okay, so if I wanted a 40 and above, so 40, and I want to go to infinity, okay, it's just, well, technically it goes up to 50, but say 40 to infinity. So how do you type in the infinity sign? Just on the bottom here next to where the pi symbol is, you can put infinity there. Okay, so where the pi symbol is, or next to the letter N, you can put the infinity. And if I press OK, that's what I meant. You got to be the top 7.6% on the graph. So if I drew this again, 40 is somewhere here, 40 to infinity. So if I went all the way to infinity, that percentage is about 0.076, means you're about 7.6% if you times that by 100. So you got to be the top 7.6. So if you want a 45 raw, so let's say, what is it like to get 45 and above? You're now the 1.6% of the state. So anyone that you've heard that's got 45 or even 50 raw, which is a perfect score, that's how hard it is. And if you're talking about a general subject like English, for example, there's like 80,000 students in a state at the end of year. So if it's 80,000 students, let's see what's like to get 50. So to get 50, here we go. To get a 50, you're the 0.02%, and let's say out of 80,000 students, so let's times it, 80,000 students, you're the top 170 of the 80,000 kids to get a Rule 50 in that most popular subject because everyone has to do English. So if you wanted to calculate, you can actually use norm CDF, and that's a way to sort of engage with the topic but also understand very on a superficial level what the normal distribution does. That's how they calculate your study scores in terms of percentages. Okay? So that's the reality of what it is. So when a student tells me, most average students tell me they want a 40, and I'm thinking, are you the top 7.6% in the class to begin with? So if you're not, then I'm like, well, that's a good goal to put. Let's see how you do by the end of the year. Okay, but to get a 40 and above, it is hard. It means you do have to be consistent. Generally, for my year 12s, I show them this if they're in the methods class, and then I tell them, to get that 40, I've always noticed that any kids who get 40 and above do at least 40 past exams. I haven't seen anyone who hasn't done at least 40 past exams in order to get the 40 and above. and you know what the average is when it comes to year 12s, what the average number of past exams they actually do? Anyone want to have a guess? Ooh, that's actually not bad, but it's actually pretty close to that. 2 or 3. It's generally 3. 1 because they do it with us at the in term 4 and term 3, so they do 1 practice 1. Then they do 1 by themselves, and if they're really good, they might do another 1. Otherwise, it's usually about 1 or 2. That's the average. So if you can do more than 3 by the end of year 12 for all your subjects, that's already beating the average. That's where the 30 mark is. But to get to the 40 and above, those kids are doing 40 plus. That's roughly there. Okay? Anyways, that's it for my today's lesson. It was just an intro recap. 2 skills that you needed to know for your exam. Number 1, standard deviation. Number 2, how to read the regions in the different spots. That's it. So 68, 95, 99.7, that's all you need to know. The extra stuff I was showing you was to consolidate your understanding. Okay? All right, we'll stop there, and you've got your long weekend, so enjoy that. Catch up with any work if you're falling behind, because I haven't got a lot of submissions this term. I'll stop the video.